Hello and welcome to the new video on the concept of force, and in this video we will be talking about uniform circular motion. So when a particle moves with a constant speed in a circular path, its motion is said to be uniform circular motion. In such a motion, the particles travels equal distance along the circular path in equal intervals of time. So, the speed of particle is uniform, that is constant, but the direction of motion of particle changes at each point of circular path. The continuous change in the direction of motion implies that the velocity of the particle is non-uniform, that is, the motion is accelerated. Direction of velocity at any instant in circular path. The figure shows here a particle moving in a circular path in a horizontal plane with uniform speed in the anticlockwise direction, and velocity has been labeled as v. The particle travels each quarter of circle, that is AB, BC, CD and DA in same interval. Thus, the speed of particle is constant, that is uniform. But the direction of motion of particle is different at different points of the circular path. At any point, the direction of motion is along the tangent drawn at that point of the circular path. The velocity of the particle in circular motion is variable, or the circular motion is accelerated even though the speed of the particle is uniform. So we have two types of uniform motion, that is uniform circular motion and uniform linear motion. But what is the difference between the two? In uniform circular motion, the particle is moving with same speed but the velocity is variable. And why the velocity is variable? Because it is changing its direction at every point. Since velocity is changing, that's why the acceleration is supposed to be variable. That is, it is an accelerated motion. Whereas, in case of uniform linear motion, speed and velocity are constant, as the motion is in the same straight line in the same direction. So, no variation in the direction, hence speed and velocity are same. Since there is no change in the velocity, hence it is an unaccelerated motion. That is, the acceleration is zero for uniform linear motion. In a circular motion, force is needed to change the direction of motion, or you can say to change the velocity of the particle. The motion in circular path is possible only under the influence of a force which is directed towards the center of the circle. Thus, the direction of acceleration also changes at each point of the circular path, but its magnitude remains the same. That is, acceleration is variable. Hence, for a body moving in a circular path, a force is needed which acts as the centripetal force. Thus, the centripetal force is the force acting on a body moving in a circular path in a direction towards the center of a circular path. Now let's talk about few examples of bodies in motion under the influence of centripetal force. In an atom, an electron moves around the nucleus in a circular path for which the required centripetal force is obtained from the electrostatic force of attraction on the negatively charged electron by the positively charged nucleus. Same way, a planet moves around the sun in a circular path for which the gravitational force of attraction on the planet by the sun provides the necessary centripetal force. The moon moves around the sun in a circular path for which the gravitational force of attraction on the moon by the earth provides the required centripetal force. Same way, when a stone tied at the end of a string is railed in a circular path holding its other end in the hand, the tension in the string provides the necessary centripetal force. If this force, that is the tension, is not present, the stone will not turn to move in a circular path. So, from the above examples, we can see the body moves in a circular path with a uniform speed under the influence of centripetal force, and it is in dynamic equilibrium. We have heard that to every action there is equal and opposite reaction. So, is it that to counterbalance centripetal force there exists another force? So, let's have discussion on this. A force assumed to be acting on the body in a direction away from the center of circular path is called centrifugal force. Centrifugal force is in a direction opposite to the direction of centripetal force. Its magnitude is the same as that of the centripetal force. But the centrifugal force is not the force of reaction of the centripetal force, because action and reaction do not act on the same body. It is not the real force, but it is a fictitious force assumed by an observer moving in circular path along with the body. So let's have detailed discussion on this topic. Now the question arises, why centrifugal force has been labeled as a fictitious force or virtual force? The thing is that whatever quantity, whatever law, whatever principle we discuss in sciences, in physics, they are actually applicable in every circumstance, in every condition. They are the standard results. But the thing is, when we discovered about centrifugal force, we had double results. Double results means it was applicable in one of the situation, but it was not existing in the other situation at the same time. So the observations made were different. So let us talk about an example that is related to merry-go-round that will explain you better. Now in the figure, you can see a ball tied at one end of a string, the other end of which is tied at the center of a merry-go-round. Initially, when the platform of merry-go-round is stationary, the ball is seen stationary and the string is loose. As the platform starts rotating, the ball rolls towards the edge of the merry-go-round and the string becomes tight due to tension T in it. The motion of the ball is observed by two persons. First, that is standing outside the merry-go-round on the ground at M, and the second person standing on the platform of merry-go-round at A. The person standing on the ground at M outside the merry-go-round observes that the ball is moving in a circular path, while the person standing on the merry-go-round at A observes that the ball is stationary placed just in front of him at B. As the merry-go-round rotates, the position of person on the platform changes from A to A dash, double dash, A triple dash, and the ball reaches at the position P dash, P double dash, P triple dash, and so on, respectively, as if it remains at rest always just in front of him. The different observations of the same motion by the two persons at M and A are explained as follows. For the person at M, the ball moves in a circular path because the tension T in the string provides the centripetal force needed for the circular motion. The person at A observes the ball stationary. He considers the following two forces to act on the ball in order to understand his observations. The tension T of the string towards the center of merry-go-round and the centrifugal force away from the center. The above two forces are equal and opposite, therefore the net force on the ball is zero. Hence, it always remains stationary in front of him. Thus, a person on the rotating platform can explain his observation only by considering the centrifugal force. Now, if The string breaks when the ball is in position at P. The force of tension T in string ceases to act. Now, the person at M standing on the ground will observe that the ball is moving in a straight line along the path PT, while the person at A standing on the merry-go-round will observe the ball at positions P dash, P double dash, P triple dash, and so on, when he will be at the position A dash, A double dash, and A triple dash, and so on, respectively. That is, he will observe that the ball always remains in front of him, moving radially away from him, as if the centrifugal force acts on the ball away from the center. Thus, the person in rotating frame has to assume the presence of the centrifugal force. So you can see here two person at two different places and two different observations. So for one person, the centrifugal force was existing, but for the second, it was not existing at the same time. Because of such type of results, centrifugal force has been termed as a virtual or fictitious force. So we can conclude that the centrifugal force is not a real force, it is a fictitious force. The only force involved here is the force of tension in the string acting towards the center, that is the centripetal force. So, a force which really does not exist but is considered to describe a certain motion is called a fictitious force or a virtual force. And in this case, we found out that centrifugal force is a fictitious force. So, thank you for watching the video and keep watching and wait for the next concept. Till then, take care.